All right, let's get into it. Today, we're talking about a genuine revolution happening right under our noses, deep in the core of the internet. It's a total rethink of how data gets from point A to point B, and leading the charge? Two absolute giants, Nokia and Cisco. But here's the thing, they're not using the same playbook. So think about it like this. What if you tried to get across a huge modern city using a paper map from like 20 years ago, right? It's totally rigid, it can't tell you about traffic, and if there's a road closure, you're just stuck. Well, for a long, long time, that's kind of how our main network protocols have been working. Super powerful, for sure, but also pretty clunky and not very flexible. And this really gets to the heart of the change. The old way, it was basically a railroad. Your data packets got put on a fixed track, and that was it. Trying to reroute around a problem was a massive, massive headache. But the new way, it's like a GPS. It gives every single packet its own set of custom, turn-by-turn directions. The whole system just gets smarter and way more agile. And the hero technology making all this GPS-like magic happen is segment routing, or just SR. It's this really elegant solution that's designed to finally clear up all those digital traffic jams on the internet for good.
So what is it exactly? Well, to put it simply, with segment routing, the very first router a data packet meets, the source, gets to be the master planner. It figures out the entire path the packet needs to take across the network. And then get this, it stamps that itinerary right into the packet's header.
So how does this whole packet GPS thing actually work in practice? Well, it's really just a simple three-step dance. First, the source router plans the entire trip. Second, it encodes that plan into a list of segments, or SIDs. You can just think of them as waypoints on a map. And third, and this is the key part, each router along the journey only has to read the very next waypoint and send the packet on its way. It doesn't need to know the full plan, which makes the whole network so much simpler. Okay, and this is where it gets really, really interesting. The two biggest players in this game, Nokia and Cisco, they both jumped on the segment routing train, but they went about it in completely different ways. And we're not just talking about different branding here, we're talking about a fundamental split in how they think the internet of the future should be built. And the first place they diverge is right at the very foundation, something called the Segment Routing Global Block, or SRGB. You can think of the SRGB as the unique set of addresses or labels that a network uses for all its SR waypoints. It's the building block that everything else depends on. Now what's so cool here is you can literally see their different philosophies right in the configuration code. To set up that sRGB, Nokia's system uses a command called prefix SID range. Cisco's system, on the other hand, uses global block. They both get the same job done, but the language and the logic are totally different, right from the very first line of code you type. And this just perfectly shows the difference right out of the box. By default, Cisco kicks off its sRGB label range at 16,000. Nokia? They start way up at 32,000. Now you might be thinking, why does that even matter? Well, if you have both Nokia and Cisco gear in the same network, which happens all the time, these different starting points can cause major routing conflicts. And trust me, it's an absolute nightmare to troubleshoot. Now, let's move beyond the basics, because where SR really becomes a superpower is with something called traffic engineering, or SRT. This is what lets network operators go from just managing traffic to becoming master conductors, steering data with incredible pinpoint precision. With SRT policies, you can literally build custom highways for your most important data. You can design paths that explicitly go around busy parts of the network. You can guarantee super low latency for things like video calls or online gaming. And you can even hook everything up to a central brain, a path computation element, or PCE, that sees the whole map and can figure out the absolute best path in real time. And that really is the promise here. It's all about taking back control from these old, rigid protocols and giving engineers the tools to steer traffic like a pro, intelligently dodging those digital traffic jams before they even have a chance to form. But the story doesn't end there. The evolution keeps going. The next massive leap is SRv6, and this is all about getting the internet ready for what's coming next. Things like 5G, the Internet of Things, and apps we haven't even dreamed up yet. The whole idea behind SRv6 is pretty simple. More, more, more. It taps into the practically infinite number of IPv6 addresses to give the network more power and, this is the big one, way more programmability. So what makes SRv6 a total game changer is that it completely gets rid of that special stack of labels we talked about before. Instead, It uses actual IPv6 addresses as the segments, as the waypoints. This doesn't just make the network simpler, it opens the door to true network programming. Now you can stick instructions in the address list, not just a path. Things like apply this security rule or log this packet's info. It's a really profound shift in thinking. And SRv6 brings with it some incredible new armor for the network. One of the key features is called TI-LFA. Now, that's a mouthful. It stands for Topology Independent Loop-Free Alternate. But really, that's just a fancy way of saying it can figure out a backup path for any possible failure ahead of time. So if a link goes down, the network recovers almost instantly. We're talking less than 50 milliseconds. That is literally faster than you can blink. It's the ultimate self-healing network. Okay, so we've been deep in the technical weeds here. I get it. But let's pull it all back to what this means for you, for all of us. Why does this showdown between Nokia and Cisco, deep inside the network, actually matter? So here's the bottom line. This tech is creating a much smarter internet, one that's more efficient and way less likely to get clogged up. For you, that just means faster, more reliable streaming, smoother online gaming, and better performance from all the cloud services you use every day. We're building a self-healing network that's basically the foundation for whatever amazing innovations come next. And that really brings us to the final thought here. The core idea, the big idea behind all of this segment routing stuff, is programmability. For the first time, we can give a simple packet of data, a set of really intelligent instructions. So the real question isn't just about routing traffic today. It's, if we can program a packet's path, what else can we program about the future of the internet itself?